So hello, now we are coming with our 10th video class. So in this video class we will discuss the types of nucleophilic substitution reactions. So nucleophilic substitution reaction is of two types. One is substitution nucleophilic unimolecular. It is represented as SN1. S is substitution nucleophilic unimolecular. And another is SN2. That is substitution nucleophilic bimolecular. The nucleophilic reaction is of two types. One is SN1, other is SN2. Now what do you mean by SN1 and what do you mean by SN2? We will discuss in details. It is SN1 reaction and SN2 reaction. Now we are discussing about the SN1 reaction, that is substitution nucleophilic unimolecular reaction. Now this SN1 reaction is generally shown by 3-degree alkyl halide. 3-degree alkyl halide generally shows SN1 reaction. So suppose it is this reaction R3CX. So this carbon is bonded with 3 alkyl group. So it is a 3-degree alkyl halide. So 3-degree alkyl halide reacts with a nucleophile OH minus. It is a nucleophile. So after this reaction, this halogen group is substituted by the nucleophile. Halogen gets substituted by the nucleophile. That is, it is a nucleophilic substitution reaction. Now, for this reaction, the rate of the reaction, that is, rate means the reaction speed of the reaction. The rate of the reaction, in this reaction there are two species. One is alkyl halide, other is nucleophile. There are two reactant species in this reaction, but the rate of the reaction, that is the speed of the reaction, rate of the reaction depends upon only one species. Although there are two species, there is alkyl halide and nucleophile, but the rate of the reaction is depends upon only one species. That is, rate depends upon the alkyl halide, but not depends upon the nucleophile. So 3-degree alkyl halide shows SN1 reaction. In the SN1 reaction, the rate of reaction depends upon the concentration of only alkyl halide, but not upon the concentration of the nucleophile. That is, the rate depends upon the concentration of one reactant species. That's why it is called SN1. One means it is unimolecular. That is, rate is depends upon the concentration of one species. This signifies the one. One signifies that the rate of the reaction depends upon the concentration of one species. That is, one species is alkyl halide. So whatever be the concentration of nucleophile, the rate does not influence upon the concentration of the nucleophile. The rate of the reaction depends upon the concentration of the reactant, concentration of alkyl halide. If the concentration of alkyl halide is increases, rate of the reaction will increase. If the concentration of alkyl halide is decreases, the rate of the reaction will decrease. But whatever be the concentration of nucleophile, it does not influence the reaction. So this is about the SN1 reaction. That is, this type of the reaction is shown by 3-degree alkyl halide. In SN1 reaction, the rate depends upon the concentration of one reactant species, that is concentration of alkyl halide, but not upon the concentration of the nucleophile. Now, in SN1 reaction, SN1 reaction, it is two-step reaction. SN1 reaction, it is two-step reaction. What are these two steps? Step 1, step A, first step. Step 1, in step 1 involves formation of carbocation. Step 1 involves formation of carbocation. And in step 2, in step 2, nucleophile attack the planar carbocation. Nucleophile attack the planar carbocation in front as well as back side to give racemic mixture. So it is a two-step reaction. In the first step, it involves the formation of carbocation. That is, in the first step, carbocation is generated, and in the second step, this nucleophile attack the carbocation in front side as well as in back side to give the racemic mixture. So let us see the meaning of this two step. Now let the reaction is R3CX plus OH minus arrow R3COH plus X minus. This halide is replaced by the nucleophile. We are getting RCOH. So this reaction is two-step reaction. This reaction is a two-step reaction. What is two-step? First step involves the formation of carbocation. So what is the mechanism of this reaction? Step 1. It involves the formation of carbocation. So how the carbocation is generated? R and X. So CR3X. So in the first step, this halide group will leave. This bond will break. After breaking the bond, the halide group is leaving. So this X minus group will leave, and now it is R plus X minus. So this halide group will remove as X minus, and the remaining part is carbon with 3 alkyl group. So carbon with 3 alkyl group. So this halogen is leaving with its electron pair. So carbon become positive charge. Halogen group is leaving in the bond. This one bond means 2 electron. Now this halogen group is leaving with the 2 electron. So carbon become electron deficient. So carbon become positive charge. So this is the first step. So here carbon carries the positive charge. So it is called carbocation. So first step involves the formation of carbocation. So in the first step, the carbon halogen bond will break. Now one bond means 2 electron. So this halogen group is leaving with the 2 electron. So now the carbon become electron deficient. So carbon become positive charge, and now the carbon carrying the positive charge. So it is called carbocation. Now this carbocation is planar in shape. Carbocation is planar in shape, and this molecule is not planar. It is sp3 hybridized. That means it is tetrahedral. A tetrahedral molecule will becomes the planar molecule. It is three-dimensional molecule and it is two-dimensional molecule. It is planar structure. This molecule is lying in the one plane and it is a three-dimensional molecule, tetrahedral shape, sp3, carbon is sp3 hybridization, here carbon is sp2 hybridization. This carbon is sp2 hybridization, here carbon is sp3 hybridization. So sp3 hybridized carbon becomes the sp2 hybridized carbon. Now in the second step, step 2. In step 2, what happens? This carbocation, that is C R. In this carbocation, the nucleophile will attack. Nucleophile is OH minus. This OH minus will attack with this carbocation in two sides, in front side as well as in back side. Suppose it is front and it is back. So in the second step, this is nucleophile, this is carbocation. So nucleophile will attack this carbocation in two sides, along in the front side as well as in the back side. So when the nucleophile attack in the front side, what will be the product? So when this nucleophile approaches along the front side, the 3-alkyl group will move in the back side. Got the point? When this nucleophile approaches in the front side, the 3-alkyl group will move in the back side. So let's say this nucleophile is forming the bond in the front side. So nucleophile is coming in the front side. Then the 3-alkyl group will move in the back side. That is R. So this is the product when this nucleophile is approaching along the front side. Plus, when the nucleophile approach along the back side, then what will be the product? So when nucleophile comes in the front side or in the back side, the 3-alkyl group will move in the front side. That is here OHC. OH is coming in the back side. So 3-alkyl group will move in the front side. So now 3-alkyl group is slightly moving in the front side. That is, we are getting two products. Both the product is same, but the structures are different. Orientation is different. So this is the second step. So in the first step, what happens? This alkyl halide, from the alkyl halide, carbon halogen bond will break. Now in the bond there are two electrons. So now this halogen group is leaving with the two electrons. So carbon become positive charge. So carbon become positive charge and X minus group is leaving. This group is called leaving group. This halide is known as leaving group because it is leaving from the molecule. So now the carbocation generated. Now this carbocation is planar in shape because it is sp2 hybridized. Now in the second step, in the carbocation, the nucleophile will attack in two sides, in the front side as well as in the back side. So when the nucleophile approach along the front side, then the 3-alkyl group will slightly move along in the back side. That is, we are getting these structures. Now when the nucleophile comes along the back side, then the 3-alkyl group will move in the front side. That is, we are getting this product. Now if we compare the orientation of the first product and orientation of our initial molecule, the orientation is similar. Our orientation of the alkyl halide and orientation of this molecule is similar. Here carbon and 3-alkyl group, orientation of carbon and 3-alkyl group, orientation of carbon and 3-alkyl group and in the front side that is halogen, in the front side there is nucleophile. So the orientation of these two molecule is same. So when the orientation, structural orientation of our product is similar to the structural orientation of our alkyl halide, then it is known as retention. It is known as retention. That is, structural orientation of the product is same as that of the structural orientation of our alkyl halide. Now coming the second molecule. Here the carbon and 3 alkyl group in the front side, but here carbon and 3 alkyl group in the back side. That is orientation of the product and orientation of the alkyl halide is opposite. Structural orientation of alkyl halide is opposite to the structural orientation of the alkyl halide. So when the structural orientation of the product becomes opposite to that of the structural orientation of alkyl halide, then it is called inversion. Then it is called inversion. That is, we are getting a mixture of the retention as well as inversion. So this mixture is called racemic mixture. This mixture is called racemic mixture. So in SN1 reaction, we get a racemic mixture. Racemic mixture means a mixture of retention as well as inversion product. So this is the mechanism of the SN1 reaction. So SN1 reaction, it involves the two steps. In the step 1, it involves the formation of carbocation. That is, carbocation is generated. In the second step, the nucleophile attack the planar carbocation in the front side as well as in the back side to give a racemic product. Racemic product means a mixture of the 50% retention and 50% inversion. So this retention product is generated in the front side attack. So it is from front side attack. Retention product is generated from front side attack, and inversion product is generated from back side attack. From backside attack. So this is about our SN1 reaction. So let us just review the SN1 reaction. SN1 reaction means this reaction is shown by 3-degree alkyl halide. In SN1 reaction, the rate of reaction depends upon the concentration of alkyl halide but not upon the concentration of the nucleophile. Next point is that it is a two-step reaction. SN1 reaction, it is a two-step reaction. So in the first step, carbocation is generated. In the second step, the nucleophile attack the carbocation in the front side as well as in the back side to give a racemic product. Racemic product means it is retention product and inversion product. What do you mean by retention? Retention means if the structural orientation of the product is same as that of the structural orientation of the alkyl halide, then it is called retention. Then when structural orientation of alkyl halide is structural orientation of the product is opposite to the structural orientation of the alkyl halide, then it is called the inversion product. So this is about our SN1 reaction. Now coming back to the SN2 reaction. Coming back to the SN2 reaction. So SN2 reaction, primary alkyl halide, primary alkyl halide generally shows SN2 reaction. Primary alkyl halide generally shows SN2 reaction. Here rate of reaction depends upon both the concentration of alkyl halide. Rate of reaction depends upon both the concentration of alkyl halide and nucleophile. So rate depends upon both the concentration of alkyl halides and the nucleophile. Now let us consider a reaction. It is a 1 degree alkyl halide. Carbon is bonded with one alkyl group, or say it is CH3X. Primary alkyl halide upon treatment with nucleophile. Then the product is this halogen group is substituted by the nucleophile, so CH3OH plus X minus. So halogen group is substituted by the nucleophile, that is, it is a nucleophilic substitution reaction, and this reaction is a SN1 reaction because here alkyl halide is primary, simplest alkyl halide. So in this reaction, the rate is depends upon, there are two species, one is alkyl halide, other is nucleophile. So rate depends upon the concentration of the alkyl halide as well as the concentration of the nucleophile. That is, it is CH3X and OH minus. The rate depends upon the concentration of two reactant species. That's why here it is 2. Here K is a constant. So it is, this reaction shows by primary alkyl halide. Rate of the reaction depends upon the concentration of two reactant species, that is the alkyl halide and nucleophile. That is, if we change the concentration of any one of the reactant species, the rate of the reaction will change. Now this SN2 reaction is one-step reaction. SN2 reaction, it is one-step reaction. It is one-step reaction. SN1 reaction is a two-step reaction, but SN2 reaction is one-step reaction. Here approach of nucleophile. Here approach of nucleophile and departure of leaving group. Here approach of nucleophile and departure of leaving group takes place simultaneously. To give inversion product. It is one-step reaction, and here approach of nucleophile and departure of living group takes place simultaneously to give the inversion product. So what is the meaning of this paragraph? Now first let's write the reaction here. CH3X plus OH minus arrow CH3OH plus X minus. This is the reaction. X group is replaced by the nucleophile. So this is the SN1 reaction. Now what is the SN1 reaction? Now this reaction is one-step reaction. SN1 reaction is one-step reaction. Now in one-step reaction, what is happening? Approach of nucleophile and departure of living group takes place simultaneously. Now let's mechanism. If we see the mechanism, then we will understand the meaning of this paragraph. So CH3X, CH8X. Now in this molecule, the nucleophile will attack. So nucleophile will attack the molecule and the X group is living. So here attack of the nucleophile and removal of the living group, it is taking place at a time. In our SN1 reaction, in the first step nucleophile living group is removing and the second step nucleophile is approaching. If we look at the SN1 reaction, it is a two-step reaction. In the first step, this halogen group is leaving, and the second step, the nucleophile is approaching. But in SN1 reaction, the approach of the nucleophile and the removal of the living group, it is taking place at a time. That is, these are taking place simultaneously, not separately. In SN1 reaction, the removal of the living group and approaching of the nucleophile taking place separately. But SN1 reaction, these two processes are taking place at a time. So nucleophile is approaching and this living group is removing. Now here one point is important. Here this nucleophile will approach in the back side of the living group. This group is called living group because it is living. So nucleophile will always approach from the back side of the living group, not in the front side of the living group. Always the nucleophile will attack in the front side of the living group, and here living group is living. Now what we are getting? This nucleophile is now forming the bond with carbon. So nucleophile is now start to forming the bond with the carbon, and there are 3 hydrogen, and the carbon and halogen, this bond is start to break. So here this dot mark, so nucleophile is approaching to the carbon, that is nucleophile is start to forming the bond. So here dot line indicate that the bond is start to forming. The bond is start to forming. Now it is a full bond. Now the X group is start to leave. It is the full bond is start to break. The dot mark here, dot mark indicates that the full bond is just starting to break. And here this dot line is indicates that the nucleophile is start to forming the bond with the carbon. So here it is a 5-member transition state. 1, 2, 3, 4, 5. That are the 5-member transition state. Now here what is happening? Here the nucleophile is start to forming the bond. Now this nucleophile will completely form the bond. Nucleophile is start to forming the bond. Now nucleophile is completely forming the bond, and there are 3 hydrogen is there. So 3 hydrogen is there. and here this carbon halogen bond is start to break. Now it is completely break and X group is leaving. So this is the mechanism of the SN2 reaction. Clear? So SN2 reaction, one step reaction. Here approaching of the nucleophile and departure of living group. These two process taking place at a time, and the nucleophile is always approached in the back side of the living group. So now here nucleophile start to forming the bond with the carbon. So this dot line indicates that nucleophile start to forming the bond. And here carbon halogen bond is start to break. So full bond is start to break. So dot mark full bond to dot means bond is breaking. The start to break. Now here this partial bond is completely formed, and here the bond is start to break. Now it is completely break down, and the living group is living. Now if we look at the structural orientation of the product and structural orientation of the alkyl halide, these are opposite. Here 3 hydrogen is in the back side, 3 hydrogen in the front side, halogen in the front side and nucleophile in the back side. So structural orientation of the alkyl halide and structural orientation of the product is opposite. That is, it is called inversion. So in SN2 reaction we get the inversion product. So here we are getting inversion product. So SN1 reaction give the racemic product, but SN2 reaction gives the inversion product. So this is about our SN1 and SN2 reactions. Now, what are the conditions for SN1 and SN2 reaction? Condition for SN1 and SN2 reaction. Favorable condition. Favorable condition for SN1 reaction. For SN1 reaction, if we first is alkyl halide. Alkyl halide. Now look at this alkyl halide.